Greetings and welcome to Introduction to Statistics. In this lesson, we'll be finding the z-score. I know we're going to get to z-scores in just a second, but let's get out of the realm of statistics really quickly and let's just talk about things that you probably know a lot about, which are exams. And consider you have taken two exams, one in a history class and one in a political science class. And on your history test, you scored a 47 out of 50, and on your political science test, you scored a 72 out of 75. Now, you missed 3 on each exam. So does that mean you did just as well on each of the exams? Well, think about it for a second. Did you do just as well because you only missed 3? Well, there's a problem here, and it's because it's not quite easy to tell if you did because the number of questions are different. And because the number of questions are different, we just can't say that just because you got 3 wrong, you did just as well. So usually in that situation, you figure out your percent. And we can convert both of these scores over to a percent and then compare the percents and to figure out which one did you do better on, worse on, did you do the same. So first, take your score for your history exam, 47 out of 50, divide that, multiply by 100, and you get 94. Your score translates over to a 94%. Do the same for your political science test. And it turns out 72 divided by 75 times 100 is 96. And therefore, because they're both in percents, we can compare those. And you did actually better on your political science test than you did on your history test, but technically you did well on both of them. That's the idea about a z-score. All right, so now let's see what z-scores are. A z-score, or just z for short, is the number of standard deviations a value is away from the mean. Now, as you can imagine, sets of data don't necessarily have the same mean and standard deviation. And so comparing values is going to be very difficult, very similar to the test. So what we do is we convert them over to z, and then we're able to compare the z's. So let's look at an example. We have the mean of 5, a standard deviation of 2, an x value of 7. Well, since 7 is 2 above 5 and 2 divided by 2 is 1, that's 1 standard deviation above the mean. Okay, so 7 is 1 standard deviation above the mean, so its z-score would be 1. Let's take another value, 1. So your value now is 1. Well, 1 is 4 below 5, and 4 divided by 2 is 2. So 1's z-score is negative 2. Yes, z-scores can be negative. That's just fine. It just means that it's below the mean versus a positive is above the mean. Okay, now let's change it up and say that our mean is now 27. Our standard deviation is 3.5. Well, 30.5 is 3.5 above 27, and 3.5 divided by 3.5 is 1, so 30.5, its z-score is 1. Let's try 20. 20 is 7 below the mean, and 7 divided by 3.5 is 2, so 20's z-score is negative 2. Now, 7 is comparable to 30.5 within their data set because their z-scores are each 1. 1 is comparable to 20 within their respective data sets because their standard deviations are both negative 2. That does not mean that 7 equals 30.5 and 1 equals 20. They're just within its own data set. They're both negative 2. Or they're 2 standard deviations below the mean, and 7 and 30.5 are 1 standard deviation above their mean. Okay, so now let's talk about how to do the math. What is the formula involved with finding a z-score? Now, I don't want you to get scared off that there are two formulas. There's actually not two formulas. There's just one, but because we have population notation and sample notation, they look different. But listen to what I say and where I'm pointing, okay? Take the x value, subtract the mean, and divide all of that by the standard deviation, and you get the z. Take the x value, subtract the mean, divide all of that by the standard deviation, you get the z. Same formula, but different notation because we have population notation and we have sample notation, but the math is exactly the same, okay? Now let's run through an example from start to finish here. On a recent physical exercise challenge, the mean number of squats for men was 76 with a standard deviation of 4.3. The mean number of squats for women was 84 with a standard deviation of 4.8. Jose did 86 squats. Angela did 94 squats. Who did relatively more squats? Now, if I just asked you who did more squats, you would say, well, of course, Angela did because 94 is more than 76. But I'm asking you who did relatively more squats within their gender. Did Jose do relatively more squats than the average man? And did Angela do more squats than the average woman? And we're going to compare those. That's where the z-score will come in. The first thing we want to do is grab all the information out of the problem that we're going to need. So we're going to be dealing with Jose and Angela. So for Jose, the men's mean is 76. For Angela, the women's mean is 84. For Jose, the men's standard deviation is 4.3, and for Angela, the women's standard deviation is 4.8. Now Jose did 86 squats, so his x value is 86. Angela did 94 squats, and therefore Angela's x is 94. We have all the parts and pieces that we need to be able to calculate the z. Once we get the z for Jose, and once we get the z for Angela, we can then compare the two values and see what's going on. All right, let's just take a look at Jose's. So x minus mu all divided by standard deviation. So 86 minus 76 all divided by 4.3 is 2.33. For Angela, we have x, 94, minus mu, 84, all divided by 4.8, the standard deviation. So 94 minus 84, all divided by 4.8, and we get 2.08. Now that both Jose's squats are in a z-score and Angela's squats are in z-score, we can compare the two. Looks like Jose is 2.33 standard deviations above the mean, and Angela is 2.08 standard deviations above the mean. And therefore, relative to their gender, Jose did more squats. Okay. Now, I do want to clarify one thing. When I put this into the calculator, I needed to make sure that I had parentheses around everything in my numerator. Otherwise, it wouldn't have worked out right. So I need a parenthesis around the 86 minus 76 and the 94 minus 84. After that, the calculator will do the rest of the math for us. So that's it for this lesson. Until next time, be seeing you.